We're going to do some examples of composed functions, and this is when we're not multiplying or adding or subtracting or dividing functions. We're going to take one function and replace the variable in another function with it. So in this situation, I want to compose f with g, and we say f of g of x, and we're going to take the entirety of g of x and put it into the function f. So here's my function f, and I'm going to put into it g of x, which is 2x squared. Now this is not multiplying it, this is replacing the x of my f of x with g of x. So everywhere there's an x in my f, I'm going to replace it with 2x squared. So now I have 3 times 2x squared. And then my function says also to add a 2, like so. And so then I have 6x squared plus 2, and this is my composed function. Now my domain here, so let's look at this. I don't have a denominator, so I don't have to worry about dividing by 0, and I don't have a square root, so I don't have to worry about negative under the square root. So then my domain is going to be all real numbers. So any x can go in. So before we think that if we compose the other direction, if we say g of f of x and put g inside of f, don't think that these are going to be equal, because they're not necessarily. So we're going to go to the next slide and try that one out. Okay, we have the same three functions, and I am going to try composing f into g this time. I'm going to use blue for my f of x. So I'm going to have g, and inside my g I am going to put 3x plus 2 everywhere there's an x. So I have 2 times x squared, so 2, my x here is 3x plus 2, and I'm going to square that according to my g function. So I am now going to multiply 3x plus 2 squared, which gives me 9x squared, plus 12x plus 4, and then distribute my 2 through, so 18x squared plus 24x. So if you remember what we had for the last function, these look nothing alike. They are not equal. But let's talk domain a minute. Okay, domain is restricted by dividing by 0. I don't have a denominator. And square roots, negatives under a square root, and I also do not have that. So my domain again is going to be all real numbers. Alright, let's try something else with this. Okay, I thought for this slide we would take g of x, 2x squared, and we would insert it into h of x, which is negative 4 over x plus 3. I'm going to use green for my g of x right here. And I'm going to replace g of x into my function with 2x squared. Now my variable and my h of x is in the denominator. So I'm at negative 4 over 2x squared plus 3. Alright, so now for my domain. The denominator cannot be equal to 0. And let's look at this. I've got 2x squared plus 3. Is there any way to get a negative 3 out of 2x squared? So let's see, 2x squared plus 3 cannot be equal to 0. So I've got 2x squared equals negative 3. Well, it can't be equal to negative 3 no matter what. So, because of the square, this is always positive, so I don't have to worry about getting a negative there at all. So in this case, you're going to have all real numbers again. Alright, we're going to do one more slide. For the last slide, I want to compose h with f. I'm going to put the f inside the h function. I'm going to make f purple. And so I'm going to replace f of x with 3x plus 2. So that means everywhere there's the x and the h, I'm going to replace that with 3x plus 2. It only happens one time. So it says x plus 3, so 3x plus 2, that's my x. I'm going to do plus 3. And then let's simplify that denominator. It gives me 3x plus 5. Okay, so for my domain, 3x plus 5 cannot be equal to 0 and still remain real. So if I simply set this equal to 0 and solve for x, that tells me what has to be omitted from my domain. And so x equals negative 5/3 would make my denominator be 0, and I would be dividing by 0, which is undefined. So my domain will be all reals except x cannot equal to negative 5/3.